This is the Carabiner 98 Kurz, better known as the K98K, a bolt-action rifle that built in World War II. Today, we're taking you inside the factory to witness the complete manufacturing process of this legendary weapon, from raw steel to finished rifle. Every component must meet exact specifications. The K98K is more than just a firearm combat conditions. In this documentary, you'll see how massive steel billets are transformed into receiver faithful for accurate. Let's begin at the source of every rifle, raw materials. Every K98K begins with high carbon. The steel arrives at the rifle factory as large billets, weighing several hundred pounds each. These billets will be forged and machined into receivers, barrels, bolts, and trigger components using ultrasonic testing. Each are the preferred choices for K98K stocks. These hardwoods are dense, durable, and resist warping in humid conditions. Steel materials include brass for cartridge casings, springs made from tempered steel wire, and chemical compounds for the bluing process. Bluing is a rust-proofing process that gives the rifle its dark finish while protecting the metal from corrosion. Steel billets head to the forging division. Wood blanks moved stockwork a sprite component to the spark fun. Now, the transformation begins. But before we dive into manufacturing, let's understand the K98K's origins and brief history. The rifle was adopted by Germany in 1935, designed by the legendary Mauser company. The K98K was a shortened version of the earlier Gewehr 98 rifle used in World War I. During World War II, the K98K served as the standard rifle for the German Wehrmacht. Over 14 million units were produced between 1935 and in 40 cartridge from a 5-round internal magazine. Its effective range was 500 meters with iron sights, what fulls with turn 800 meters. Today, the K98K remains a symbol of German engineering and is highly sought after by collectors and historians worldwide. Now, let's see how this legendary rifle is made. The receiver is the heart of the rifle. It houses the bolt, barrels, and a heated steel in the basic form. The impact is tremendous, creating the rough outline in a single blow. After forging, the rough receiver blank is transformed to the bolt raceway is machined into the top of the receiver. This is the channel where the bolt slides back and forth. Through excessive wear, the receiver ring, where the barrel will screw in, is now machined with precision threading. These threads must be placed in lean to maintain headspace. Once machining is complete, the receiver undergoes heat treatment. The receiver is heated to over 1500 degrees Fahrenheit, increasing its strength and wear resistance. Finally, the receiver is creates a thin layer of black oxide on the steel surface, giving the rifle its distinctive appearance while providing crucial protection against rust. The receiver is now complete, with a beautiful deep black lustrous finish. The barrel is where accuracy is born. The blank is loaded into a deep hole drilling machine, fed with high-pressed steel rut. This process can take over an hour. These grooves cause the bullet to spin as it travels down the barrel, stabilizing its flight for long-range accuracy. Two methods are used: button rifling, where a hardened tool is pushed through the bore, pressing grooves into the steel. After rifling, the chamber is reamed. This is the area at the rear of the barrel where the cartridge sits. Like the receiver, the barrel undergoes heat treatment and bluing. Tests are high-pressure loads to ensure it can handle the stresses of combat use. Only barrels that pass every test proceed to final assembly. The bolt body is machined from a solid steel cylinder. Two working lugs recesses in the receiver, creating a secure lock that contains the explosive pressure when the rifle fires. As the bolt is pulled back, the extractor pulls the spent casing from the chamber. This component is made from tool steel and heat-treated for durability, igniting the gunpowder. It's machined to exact length and weight specifications for consistent performance. Inside the bolt, a powerful spring surrounds the firing pin. When the trigger is pulled, this spring drives the firing pin forward with precision. The bolt handle is welded to the bolt body. All components are assembled into the bolt sleeve, which houses the firing pin, spring, and safety mechanism. Must cycle smoothly, extract reliably, and the firing pin with consistent force. Each component is verified. The trigger housing is milled from steel. The sear is a small but critical lever that holds the firing pin in the cocked position. The trigger spring provides resistance, giving the trigger its pull weight. For military rifles, a Henkley blocks the firing pin from moving forward when engaged. One triggers a pull weight test using calibrated gauges. The mechanism must release cleanly without excessive creep. While metal components are being machined, the wooden stock is taking shape and unloaded into a season router. The most critical cut is the barrel channel and receiver inlet. This is the cavity where the metal action will sit. The fit must be precise. Tossed needs salmon with the grip areas marks and creates a smooth surface. Edges are rounded and the grip area backs. Finally, the stock is finished with linseed oil or varnish, protecting the wood and enhancing its natural grain. Metal hardware is now installed. The butt plate is screwed to the rear, protecting the end grain. Sling. With all components complete, final assembly begins. The barrel is carefully screwed into the receiver's specialized fixture and torque wrench. The barreled action is fitted into the stock. Action screws pass through and thread into the receiver, torqued precisely for a secure fit. The bolt assembly is inserted and cycled sear engagement and smooth operation. The trigger ways for proper floor plate installed to the receiver and barrel. Every rifle is now ready for function testing and final quality control before approval. Before setting rifle, you pass 3D gaze. Correct headspace is ready for bogucy and reliability. The rifle is then proof tested with high pressure ammunition that exceeds normal combat loads. If the rifle survives without damage, it's marked with a proof stamp certifying it is safe for service use. Rifles with exceptional accuracy identified during test firing are set aside. These will be hand selected for conversion. Now let's examine the manufacturing process in greater detail. We return to the forging division where receiver production begins. At this temperature, the steel becomes malleable enough to be shaped under the tremendous force of the forging hammer. The forge operator activates the drop hammer. With a deafening impact, thousands of tons of force compressed. The forged blank is transferred to a cooling rack where it air cools slowly to prevent cracking. Rapid cooling would create stresses causing later failure. Once cooled, the forged receiver enters the machining department. Here, CNC milling centers remove excess material. The magazine well requires complex milling. A series of progressively smaller end mills carve out the cavity. The bolt raceway requires extreme precision. The surfaces must be parallel within 0.005 of an inch and smooth to reduce friction. And precision threads are cut using a specialized tool. The thread pitch must match the barrel exactly for proper engagement and headspace. Mounting holes with computer-controlled positioning ensures perfect repeatability across thousands of receivers. After all machining operations are complete, any decommissionment was very clean to remove all of the heat treatment particles and offendness to prevent oxidation during heating. Temperature uniformity throughout the furnace is critical for consistent results. As temperature rises above 1500 degrees Fahrenheit, the steel's crystalline structure begins to transform. The oil quench cools the steel fast enough to trap the carbon atoms, creating a hard martensite structure. The quenched receivers are now extremely to hard oil tempering, around 400 to 600 degrees Fahrenheit. After heat treatment, hardness testing verifies the steel meets specification. The reading name must fall load and trace. First, the receivers are degreased in an alkaline solution to ensure perfectly clean surfaces. Even fingerprints would prevent proper bluing adhesion. The hot bluing solution is a mixture of sodium hydroxide and oxidizing salts maintained to merges. After sufficient time in the bluing bath, the receivers are removed and rinsed in hot water and provide additional corrosion protection. Areas with core defects are documented. Any errors be remachined and reblued or rejected depending on severity. Approved receivers are moved to the assembly area. Meanwhile, in the barrel manufacturing facility, the process is continuing. Any barrel with bore dimensions outside specification or significant runout is rejected at this stage. The approved barrels advance to the rifling operation. This button has the rifling pattern in negative relief on its surface. A powerful hydraulic ram pushes the button through the barrel bore, pressing its pattern into the surface to create rifling grooves through cold forming. Button rifling is faster than cut rifling, producing excellent surface finish and wear resistance by work hardening the bore in a single pass. Off areas or defects are of the interior. Any tool marks, rough area and uniform throughout the barrel's length. The chamber reaming operation requires precision fixturing. The barrel is clamped with the chamber end accessible. The reamer is advanced to rate headspace gauges, chamber casts, and measurements to ensure perfect cartridge fit. With the bore complete and chamber cut, exterior turning operations begin. The barrel is mounted in a tapered contour. The contour is not merely decorative. The specific taper balances weight, stiffness, and heat dissipation. The muzzle end receives special attention. The muzzle crown, the last point the bullet contacts before leaving the barrel. The barrel threads for receiver attachment are cut at the opposite end. Any misalignment causes poor bedding in the receiver and degrades accuracy. Front sight base mounting provisions are machined into the barrel. The K98K uses a dovetail sight base, requiring completed barrels undergo the same heat treatment and bluing processes as receivers. The bluing bot provides and regular cleaning with oil. And standard ammunition is fired. The barrel must survive without bulging, cracking, or dimensional change to pass. Barrels that pass the barrel can just a mark of service ammunition. Barrels are then ready for final assembly with receivers. The barrel is inserted into a barrel vise which grips the barrel damage. The receiver is secured and now firmly without taging it. The receiver is carefully threaded onto the barrel. Resistor is tightened in stages, with headspace checked at intervals to achieve the target dimension. When headspace is within specification, typically very close to the go gauge dimension, final torque is applied. The bolt is verified one go gauge but not on the no-go gauges, confirming proper clearance for safe ammunition use. With metal components assembled, attention turns to stock fitting. The finished wood stock has been prepared with inlet cavities. High spots are carefully removed with chisels and scrapers. The process is repeated until the action sits properly in the stock. Once satisfied with the fit, the action is secured to the stock with action screws. These long screwdrivers pass through the cinder. The torque setting balances several factors. Too loose, and the action shifts under wood is crushed from overcompression. With the barreled action secured, the rifle begins to look complete. The bolt is inserted for the first time, slide on fee. The trigger mechanism is installed into the receiver. Small pins secure it, the sear engagement and trigger pull are verified. The magazine system components are installed. The follower spring, follower platform, and magazine floor plate assembly. Feeding reliability is tested with dummy cartridges. 5 rounds are loaded into the magazine. The bolt is cycled repeatedly. Sight installation comes next. The front sight post is driven into its dovetail slot from the side. Initial bore sighting is performed, aligning the bore with the target. The sights are then adjusted to match the same point for a rough zero. The butt plate, steel butt plate protects the stock from impact damage. Sling swivels allow rifle carrying and shooting support. Before final inspection, the completed rifle receives a thorough cleaning. All assembly lubricants and contaminants are removed. Serial numbers and manufacturing codes are stamped into various components. The receiver, bolt, and other parts receive matching numbers for traceability. The rifle now enters final inspection. A trained inspector examines every aspect of the rifle against a detailed checklist. Insert the go gauge. The bolt closes fully. Now, the no-go gauge. The bolt must not close. Mark the form. Safety check passed. A function test exercises all mechanical systems. The bolt is cycled, the trigger is pulled, the magazine is loaded and unloaded. Finish quality is scrutinized. The bluing must be uniform in color and coverage with no thin spots, staining, or bare metal. The rifle is securely mounted in a test fixture and fired remotely to eliminate risk to personnel during the first shots. A series of proof load cartridges are fired first, generating higher than normal for stand-in with a C Martian. Standard military ammunition is then test fired at targets downrange. The rifle must group shots within acceptable accuracy in 100 meters. For any signs of problems, excessive smoke, unusual sounds, or poor extraction, the rifle must function flawlessly to pass. After firing, the rifle is inspected for any damage or loosening from recoil stress. Action screws are checked for tightness. Rifles with unusually tight shot groups are identified as sniper candidates. They receive special marking for further evaluation. Sniper candidate rifles with precision sustained at 100 and 500 meters. Only rifles consistently mapped in 500 meters. Selected sniper rifles go to specialized gunsmiths for scope mounting. Scope bases or rail systems are attached. High-quality optical sights are mounted in precision rings. The scope must be aligned perfectly. Sniper rifles may receive additional modifications, a cheek rest or pad to the stock, although sling may be fitted to sniper's preferences. Completed sniper rifles are documented with their accuracy data. The rifle's serial number is recorded along with its proven accuracy at various ranges. Best standard pre-so spraying and defined for storage engine. A heavy coat of preparation of grease for storage and shipment. Throughout the war years, the K98K manufacturers supported rifles machine parts and simplified finishes. Despite manufacturing shortcuts, the rifles remained functional and reliable. The basic design was so sound that over 14 million K98K rifles were produced from 1935 to 1980 rifles. The K98K served throughout World War II in every theater where German forces fought. The rifle's reputation for reliability in harsh conditions was well earned. Its simple manual bolt action was after the war ended in 1945, K98K production ceased in Germany. However, many nations used captured or surplus K98K rifles for decades after the war. As a hunting and sporting rifle, the reliable Mauser action was perfect for hunters pursuing large game worldwide. The Mauser 98 Axis Calpig adopted the design, creating rifles the same basis today. Today, over 80 years after its adoption, the K98 with original scopes are especially rare and valuable. Shooting enthusiasts still use K98K rifles in competition, appreciating the challenge of iron sights and manual bolt action. The manufacturing techniques used to produce the K98K represent mid-20th century industrial metalworking at its. The attention to quality, per Rasayan's of the Mamagames, inform how firearms are manufactured today. From massive drop forges to K98K Ross, the K98K meant with precision craftsmanship. Every component, from the smallest pin to the heavy barrel, must meet strict specifications. Quality control. The result is a rifle that served reliably under the most demanding conditions imaginable. Combat. Soldiers. It's a testament to industrial, engineering, metallurgical science, and manufacturing excellence. From raw materials through hundreds of operations to final inspection, we followed the complete journey of the K98K rifle.
The manufacturer requires a step into the combination procurement, inspectors requiring the combination client.
The factories themselves represented significant investment in specialized machinery. purpose-built equipment for barrel.
The raw material requirements were substantial. Thousands of tons of high-grade steel. Vast
Quality assurance extended beyond the factory. Compatibility testing verified rifles function with just from various manufacturers. Armorer training ensured personnel could maintain rifles in the field. Manuals, parts, and tools were developed and distributed. The K98K's longevity in service. Some examples remained in use for over 40 years. Rifle firearms. Today's firearms manufacturing change frightening promoging, yet the fundamental constraint advancement process. The K90s will achieve its example represent teutonic precision and organizational discipline. The rifle remains a significant artifact of 20th century military and industrial history. The K98K is a great case study for manufacturing. It shows design for production, quality assurance, and complex supply chains. The Mauser 98 action's influence extends far beyond military service. Its controlled round feed. Collectors and historians continue researching AK variations, manufacturing details. Online community are about reserve examples. The rifle's appearance in countless historical photographs and films has made it instantly recognizable. Its distinctive silhouette. The K98K's smooth bolt and accuracy make it a joy to shoot even after 80 years. Its engineering ensures it performs as designed decades later. Ammunition for the 792 by 57 mm available. That cartridge is low efficiency and moderate recoil. The bolt-action rifle, once standard, is now obsolete for military use but highly valued for hunting and target shooting due to its precision. Rifles has become a specialized craft. Experts repair damaged stocks, re-blue worn metal, and source correct replacement parts. The K98 proteges the white is forbidden to arrive fuel real glorious mastery. The manufacturing journey we've followed, from raw materials through hundreds of operations to completed rifle, demonstrates the complexity. Every part was purpose-designed. Nothing is superfluous. The rifle represents efficient engineering where form follows functions. The metallurgy alone, selecting for loggerheads, was accumulated through decades of experience producing millions of firearms. The quality control systems ensured that rifles met specification despite being produced in multiple factories by different workforces. Later production, more mass production. Early rifles show thing efficiency. This evolution reflects broader industrialization trends. World War II accelerated manufacturing innovation as the K98K was not revolutionary technology, but its excellence lies in optimization and execution, not innovation. We study the K98K to learn about durability and efficiency. Its design principles still inform our modern manufacturing. It completed Untold leaving factions. From that point, the rifle began annals and tyrants and cannons. Each rifle has its own unique history determined by the chance circumstances of where it was issued and how it was used. The rifles that survive today are tangible connections to the past. Holding an 80-year-old K98K rifle, the manufacturing knowledge used to produce K98K rifles didn't disappear after production ceased. Some K98K manufacturing facilities continue operating today as modern firearms factories. The K98K exemplifies a particular philosophy of military rifle design. Prioritize reliability over rate. Different design priorities produce different weapons. Modern military rifles prioritize rapid fire and high capacity. We've journeyed through the complete manufacturing process. Forging, resisting barrels, each contributed to the final product. The precision required, measurements in thousandths of an inch, headspace within housings remain similar. From raw steel to finished firearm, it represents industrial achievement and engineering excellence. Rifles are wrapped in wax paper and placed in wooden crates, 10 per crate, with documentation including serial numbers and inspection certificates. The crates are stenciled with contents, quantity, and destination information. They are shipped to military depots.